Have you ever looked up at the night sky and felt a strange mix of awe and unease? There's something profoundly unsettling about staring into that infinite blackness, dotted with distant stars and galaxies, and realizing just how small and fragile we truly are. The universe holds secrets that defy our understanding, mysteries that challenge everything we think we know about reality itself. And while we often celebrate the beauty and wonder of the cosmos, there's another side to this vast expanse, one filled with eerie, almost frightening theories that can make even the most rational minds pause and shiver. Today, we're diving deep into that unsettling side of space, exploring 25 creepy theories about the universe that will leave you questioning the very nature of existence. From the possibility that we're living in a simulated reality to the spine-chilling idea of a great filter silently eliminating civilizations before they can spread across the stars. These concepts aren't just science fiction, they're legitimate, mind-bending ideas debated by physicists, astronomers, and philosophers. Each one peels back another layer of the cosmic unknown, revealing a universe that is far stranger and far more mysterious than we could have ever imagined. So, if you're ready to venture into the shadows of space and explore the theories that keep scientists up at night, you're in the right place. This journey isn't for the faint of heart, but for those curious enough to confront the eerie and extraordinary truths hiding just beyond our reach. Let's begin. Our first theory might just be the most terrifying answer to one of science's greatest questions: where is everybody? Given the sheer number of stars and planets in our galaxy alone, the cosmos should be teeming with life. Yet, we hear nothing but an unsettling, profound silence. This paradox is known as the Fermi paradox, and one possible explanation is the existence of a great filter. This concept proposes that there is some kind of nearly insurmountable barrier, a critical point in the evolution of intelligent life that prevents civilizations from reaching the stars and becoming detectable across the vast distances of space. This filter could be a single cataclysmic event or a series of challenges so difficult that almost no species can get past them. The terrifying implication is that this barrier might still lie ahead of us, a gauntlet that humanity has not yet run. Perhaps the filter is the natural development of complex life itself, a series of miraculous evolutionary steps that are so astronomically rare that we are virtually alone. Or more chillingly, it could be something that awaits all technological civilizations. This might be an innate self-destructive tendency, where the discovery of advanced technology like nuclear fission or artificial intelligence inevitably leads to a species' own annihilation. It could be an external cosmic event, like a gamma ray burst sterilizing planets on a regular basis, or even something we haven't yet conceived. The eerie silence we observe could be a graveyard of civilizations that reached our level of development and then vanished, snuffed out by this invisible, universal law. This theory forces us to look at our own progress with a new sense of urgency and dread. Every technological breakthrough, while amazing, could also be bringing us one step closer to our own potential filter. The silence isn't just empty space, it's a warning. This idea takes the unsettling notion of cosmic silence and turns it inward, forcing us to question not just our place in the universe, but the very nature of our own consciousness. What if you, the person listening to this right now, with all your memories and senses, simply popped into existence just a moment ago? It sounds like the plot of a science fiction story, but it's actually a legitimate and deeply creepy thought experiment rooted in physics known as the Boltzmann Brain. The concept emerges from a field of study called thermodynamics, specifically the idea of entropy, which is a measure of disorder in a universe that generally tends toward chaos. But within that chaos, there is a statistical possibility, however incredibly tiny, for order to arise spontaneously through random quantum fluctuations. In a truly vast and ancient universe, given enough time and space, these random fluctuations could theoretically assemble anything: a cup of coffee, a chair, or even an entire, fully formed human brain, complete with a lifetime of fabricated memories and a conscious experience of the world. This spontaneously created observer is what physicists call a Boltzmann brain. The terrifying implication is that in an infinitely old and large universe, the number of these fleeting, self-aware illusions should vastly outnumber the genuinely evolved, biological brains like our own. Statistically, you are far more likely to be a momentary blip of consciousness, a brain floating in the void believing it has a body and a history, than you are to be a real person with a real past. You could have just formed an instant ago. Your memory of starting this video nothing but an elaborate, random construction. This isn't just a philosophical puzzle. It presents a serious problem for our current cosmological models. If our understanding of the universe predicts that illusions should be more common than reality, then that understanding is likely flawed or incomplete. Some physicists argue this paradox is evidence that we are missing a crucial piece of the cosmic puzzle, perhaps pointing toward a universe that had a definite beginning and isn't eternal, which would limit the time available for such bizarre fluctuations to occur. The theory doesn't offer comfort. It peels back another layer of reality and suggests that at its core, existence might be profoundly random and transient, making the solid ground of our own senses feel like the most fragile of illusions. And if the nature of your own consciousness feels uncertain, what about the reality you perceive around you? This brings us to a theory that has moved from the fringes of philosophy to serious debate among technologists and physicists: the simulation hypothesis. The core idea is as simple as it is disturbing. What if our entire universe, with all its galaxies, history, and personal experiences, is not base reality, but an incredibly advanced computer simulation, not unlike a video game, created by a civilization far more technologically mature than our own? The argument often begins with a logical projection. If a civilization continues to advance, its computing power would eventually become incomprehensibly vast. It's conceivable that such a society might run incredibly detailed simulations of its own ancestors, perhaps for research, entertainment, or even as a form of historical preservation. And if that's possible, then the number of simulated realities, each filled with conscious beings who believe their world is real, would vastly outnumber the one true original reality. Therefore, statistically, the odds are that we are not the original biological beings, but the artificial constructs living inside one of these countless simulations. Proponents sometimes point to potential glitches in the matrix, odd, seemingly impossible occurrences that could be explained as tiny errors in the code. These might include déjà vu, the mysterious Mandela effect where large groups misremember historical details in the same way, or even strange quantum behaviors where particles don't assume a fixed state until they are observed, almost as if the program is rendering reality only when needed to save on processing power. The philosophical dread this induces is profound. It means every joy, every sorrow, every triumph and failure could be nothing more than a programmed narrative. Our search for meaning in the cosmos would be a quest written into our code by an unseen programmer. Even our attempts to discover if we are in a simulation could be a predetermined part of the simulation itself. This isn't just a modern parlor game. Renowned figures like Elon Musk and the late Stephen Hawking have seriously engaged with the idea, not because they necessarily believe it, but because it raises fundamental questions about the nature of existence and consciousness. If we are in a simulation, does our suffering matter less? Does our love? The theory doesn't provide answers, but it forces a confrontation with the possibility that the universe is not only stranger than we imagine, but stranger than we can imagine, operating on rules we are not meant to decipher. Yet even the possibility of a simulated existence rests on the idea that the universe has a physical structure to simulate. But what if that very fabric of spacetime is fundamentally unstable, destined not just to end, but to end in the most violently thorough way imaginable? This brings us to our next theory, a truly apocalyptic finale known as the Big Rip. For decades, we've known our universe is expanding, but more recent observations have revealed something far more unsettling. This expansion isn't slowing down, it's accelerating. Something is actively pushing everything apart with ever-increasing force. Scientists call this mysterious something dark energy, and its true nature is one of the greatest puzzles in cosmology. The fate of the entire cosmos hinges on the properties of this dark energy. In one particularly grim scenario, if the force of dark energy doesn't just remain constant, but actually increases over time, becoming stronger and stronger, it would eventually overcome every single force that holds the universe together. First, the acceleration would become so extreme that the gravitational bonds holding clusters of galaxies together would be severed. Galaxies would be flung apart into the ever-expanding void, each left isolated in a sea of nothingness. But it wouldn't stop there. Next, the expansion force would grow so powerful that it would tear apart the individual galaxies themselves. The gravitational glue holding stars within a galaxy would be no match for the overwhelming pressure of dark energy. Solar systems would be ripped from their orbits and scattered. Then, the force would turn its attention to those individual solar systems. The gravitational bond between a star and its planets would snap. Planets would be flung away from their suns into the cold, dark emptiness. The violence would then move inward. The force holding a planet together, its own gravity, would be overcome. Earth and every other planet would be physically torn asunder. Mountains, continents, and molecules would be pulled apart. And in the final, horrifying moments, the expansion would target the very building blocks of matter itself. The forces that hold atoms together, the powerful nuclear force and the electromagnetic force, would be defeated. Atomic nuclei would be shredded from their electrons. Protons and neutrons themselves would be torn apart. The universe would be reduced to a thin, expanding cloud of fundamental particles unable to ever interact again. A cold and lifeless void where the very concept of time and space may lose all meaning. The most frightening part of this theory is its inevitability, given this specific condition of dark energy. If this is the path our universe is on, it's not a question of if but when. Current, very tentative estimates place this total dissolution trillions of years in the future, a timescale so vast it's meaningless to human minds. Yet, the idea that the universe itself contains the seeds of its own ultimate, utter annihilation, a force that will meticulously dismantle every single structure from the largest galaxy to the smallest atom, presents a profound and terrifying form of cosmic doom. It's a fate that makes even the death of a star seem mercifully quick and tidy. But if the universe avoids a violent end like the Big Rip, there is another, perhaps even more bleak, destiny that awaits it according to the fundamental laws of physics. A slow, cold, and irreversible fade into nothingness known as heat death. This theory is rooted in the second law of thermodynamics, a principle as unforgiving as it is simple. It states that the total entropy, or disorder, in a closed system like our universe can only increase over time. Imagine a drop of ink diffusing in a glass of water. It starts as a concentrated, ordered blob, but will inevitably spread out until it's evenly distributed throughout the entire glass, achieving a state of maximum disorder where no further interesting changes can occur. The universe is doing the same thing on a cosmic scale. Stars are the engines of order, burning their nuclear fuel to create light and complex elements, but they are also constantly radiating energy out into the cold void of space. a process that increases the overall entropy. Eventually, all the usable fuel for stars will be exhausted. The last stars will flicker out, leaving behind a cosmos populated by cold, dead remnants, black holes, neutron stars, and frozen planets adrift in darkness. For a time, these black holes will dominate, slowly evaporating over incomprehensible eons through a process known as Hawking radiation, but even they will eventually dissipate, returning their energy to the universe. This is where the true eternity of silence begins, with all energy evenly spread out across an unimaginably vast and expanding space. The universe will reach a state of perfect equilibrium. The temperature will approach absolute zero, just a fraction of a degree above the point where all motion ceases. In this state, no work can be done. There will be no energy gradients, no hot spots or cold spots to drive any process, be it the fusion in a star, the chemical reactions for life, or even the simple flipping of an atom. Every place will be exactly the same as every other place, a featureless, lukewarm sea of particles so diffuse they might never encounter another one again. Time itself may become meaningless, as with no change, there are no events to mark its passage. This isn't an explosion or a dramatic collapse. It is the ultimate silence, a forever of stagnant uniformity, where the story of the cosmos simply has no more pages to turn. The heat death presents a profoundly different kind of terror than the Big Rip. It's not the fear of being torn apart, but the dread of an endless, uneventful existence where every potential for action, discovery, and life has been permanently exhausted, leaving behind a corpse of a universe that continues to expand into eternal nothingness. Yet even these slow, cold fates for the cosmos assume the fundamental laws of physics remain stable and unchanging. But what if the very rules governing our reality are perched on a knife's edge, waiting for a single, random quantum event to bring it all crashing down in an instant? This leads us to one of the most abrupt and theoretically possible doomsday scenarios, false vacuum decay. To understand this, we need to think about the universe not as a collection of stars and planets, but as a field of energy. Physicists describe all of space as being filled with various quantum fields. The Higgs field, for instance, is what gives particles their mass. The current state of this field, and others, is thought to be in what's called a false vacuum. Imagine a ball resting in a small dip on the side of a very tall hill. It seems stable for now, but it's not in the lowest possible energy state it could be in. That lowest state, the bottom of the hill, is the true vacuum. Our universe is that ball, sitting in its precarious little valley. It's metastable, meaning it's stable for now, but not truly stable. A random quantum fluctuation, an event with a probability so low it might not happen for billions of years, could give that ball just enough of a nudge to push it over the edge and send it rolling down the hill toward the true vacuum. If that happens, it would trigger a cataclysm unlike any other. The point where this fluctuation occurs would instantly become a tiny bubble of true vacuum. The laws of physics inside this bubble would be completely different from our own. Constants like the speed of light or the strength of gravity could change, making the existence of matter as we know it impossible. This bubble would then expand in all directions at the speed of light, rewriting the fundamental fabric of reality as it goes. Because it expands at light speed, there would be no warning. One moment, the universe is normal. The next, a wall of absolute transformation is upon you, and then you are gone. There would be no flash, no sound, no time to react. The event horizon of this bubble would be invisible. You wouldn't see it coming because the light warning you of its approach would be traveling at the same speed as the disaster itself. The entire observable universe, everything we could ever see or know, would be erased and replaced by a new reality with completely unknown and almost certainly hostile physical laws where atoms cannot even form. The most chilling aspect of false vacuum decay is its sheer randomness and inevitability. It could be triggered by a high-energy particle collision in an experiment, or it could happen naturally a million years from now in a distant galaxy. There is no way to predict it, and absolutely nothing we could do to stop it. Our entire existence is balanced on a quantum whim, a temporary state that could vanish in the blink of an eye, leaving no trace that we or anything was ever here. But if the universe itself is a precarious and fleeting phenomenon, what does that mean for your own personal, subjective experience? This leads us to a theory that is less about cosmic doom and more about a deeply personal, psychological horror rooted in the bizarre rules of the quantum world. It's called quantum immortality, and it emerges from one of the leading interpretations of quantum mechanics, the many worlds interpretation. This view proposes that every time a quantum event occurs with multiple possible outcomes, the universe doesn't just choose one, it splits, branching off into a new, parallel reality for every single possibility. Every flip of a coin, every random atom decay, every decision you make creates a new version of the cosmos where the alternative happened. Now, apply this chilling logic to the concept of death. Imagine you find yourself in an extremely dangerous situation. Perhaps you're in a car hurtling toward a cliff, or you're the subject of a twisted experiment, a modern-day Schrödinger's cat placed in a box with a vial of poison that has a 50% chance of breaking. From an outside perspective, there are two outcomes: you live or you die. But from your own first-person, subjective viewpoint, the many worlds interpretation suggests something unnerving. Your stream of consciousness can only continue along a path where you are still alive to experience it. In the branch of reality where the poison vial breaks, your consciousness ceases. But in the branch where it does not, you survive. From your perspective, you will always find yourself in the reality where you miraculously cheated death. This would hold true no matter how improbable your survival might be. You could be in a plane explosion, a building collapse, or a gunfight, and while countless versions of you perish in parallel universes, the version that is you, the one experiencing a continuous reality, would always seem to survive through a series of increasingly astronomically unlikely events. You might walk away from a horrific crash with only a scratch, baffling doctors, while in another world, your family attends your funeral. This theory suggests a form of involuntary immortality, where your consciousness is perpetually shunted into the realities where you continue to exist, no matter how old you become or how perilous the world gets. The ultimate, terrifying endgame of this thought experiment is a reality where you are the last living being on Earth, kept alive not by vitality, but by sheer quantum chance, trapped in a frail, ancient body in a dead world, forever waiting for a death that your consciousness never seems to experience. It's a paradox that twists the concept of luck into something deeply sinister, making you a prisoner of your own awareness, forced to navigate an endless maze of realities where you are always the sole, inexplicable survivor. Yet for all the focus on our own reality and potential futures, we have largely ignored the unsettling possibility that the universe we think we know is only a tiny fraction of what's actually out there. What if the stars and galaxies we see are merely the ghostly, insignificant backdrop to a far larger and more mysterious cosmic reality, one that is completely invisible to us? This leads us to the deeply unnerving idea of the zombie universe. The name doesn't refer to the walking undead, but to the haunting possibility that the universe is dominated by entities we cannot see, touch, or directly detect, yet they control the ultimate fate of everything. These entities are dark matter and dark energy, the two greatest mysteries in modern cosmology. To call them zombies is to highlight their eerie nature. They are all around us, passing through us by the billions every second, utterly oblivious to our existence and us to theirs, yet they hold all the power. Everything we've ever observed with every telescope ever built, every star, every planet, every nebula, all of that is what scientists call baryonic matter. It makes up everything from the screen you're looking at to the neurons firing in your brain. But here is the shocking truth. This normal matter, the stuff of us, accounts for less than 5% of the entire universe. The other 95% is this dark, unknown stuff. About 27% is dark matter. We know it's there because we can see its gravitational pull. It's the invisible scaffolding that holds galaxies together. Without its immense gravitational glue, galaxies would simply fly apart as they spin. It doesn't emit, absorb, or reflect any light, hence the name dark. It is a ghost, a cosmic zombie, interacting with our world only through the force of gravity. Then there's dark energy, making up a staggering 68% of the universe. This is the even more mysterious force responsible for the accelerating expansion of the cosmos, the very force that could lead to a big rip. We have no idea what it is. We only know it's there because we can measure its devastating effect on the universe's expansion. It acts as a sort of anti-gravity, pushing space itself apart. The terrifying implication is that we are essentially blind. We are living in a universe dominated by forces and substances we do not understand, that we cannot interact with, and that are fundamentally reshaping reality on the grandest scales. It's as if we are tiny actors on a stage, performing our lives under bright lights, completely unaware that the entire theater, the sets, and the very ground beneath our feet are made of and controlled by invisible, silent phantoms whose motives and nature are utterly alien to us. Our entire understanding of physics, based on the 5% we can see, might be a quaint local rulebook that is completely irrelevant to the true, dark 95% that holds all the power. We are not the main characters in the cosmic story. We are merely fleeting, insignificant whispers in a universe ruled by silent, unstoppable zombies. And if the silent, dominant influence of dark matter and dark energy makes us question our significance, our next theory confronts us with an object so powerful it can erase the fundamental building blocks of reality itself, creating a paradox that threatens to shatter our understanding of physics. This is the black hole information paradox, a conflict so deep it pits two pillars of modern science, quantum mechanics and general relativity, against each other in a battle with no easy resolution. At its heart, this isn't just about black holes. It's about whether the universe is fundamentally predictable and orderly, or if true, permanent chaos can exist. To understand the paradox, we first need to understand two unshakable principles. The first comes from quantum mechanics, the principle of unitarity. This states that information about the state of a quantum system can never be truly lost. If you could somehow track every single particle and its properties, you could theoretically reverse time and see where everything came from. Information might be scrambled, mixed up, or incredibly difficult to decode, but it is never destroyed. It's a fundamental tenet of a logical, knowable universe. The second principle comes from Einstein's general relativity, which describes black holes as regions of spacetime where gravity is so intense that nothing, not even light, can escape from within a boundary called the event horizon. Now, imagine a book is thrown into a black hole. That book is made of atoms, and those atoms contain quantum information, the specific arrangement of particles that makes that book unique. According to general relativity, the book crosses the event horizon and is irretrievably lost, destined to be crushed into the black hole's central singularity. The information about the book seems to be permanently destroyed, which directly violates the quantum law that information must be preserved. This was the crux of the paradox first clearly identified by Stephen Hawking. He showed that black holes aren't completely black. They slowly emit radiation and evaporate over astronomically long timescales. This Hawking radiation, however, is purely thermal and random. It contains no information about what fell into the black hole. It would be like burning a book and having only the heat and ashes remain. You could never reconstruct the words on the pages from that random energy. So, if a black hole evaporates completely, leaving behind only this featureless radiation, where did the information about the book go? It appears to be utterly annihilated. This creates a crisis in physics, often called information loss. If information can be destroyed, it means the universe is not reversible or deterministic at its core. The entire framework of quantum physics, which has been spectacularly successful, would be built on a false foundation. It would mean that at the heart of every black hole, the universe allows for a little bit of fundamental chaos, a place where the rules simply break down. For decades, physicists have struggled with this. One potential solution, proposed by Leonard Susskind and others, is the idea of the holographic principle. This suggests that all the information about everything that falls into a black hole isn't actually lost inside it, but is somehow encoded and preserved on the event horizon's surface, like a cosmic hologram. The three-dimensional information of the book is translated into a two-dimensional pattern on the black hole's boundary. Then, as the black hole emits Hawking radiation, this radiation somehow carries that encoded information back out into the universe, albeit in a form we cannot yet decipher. This solution preserves the laws of quantum mechanics, but requires us to completely rethink the nature of reality, suggesting that our perception of a three-dimensional universe might be a projection from a two-dimensional surface at its boundary. The paradox remains one of the most profound puzzles in theoretical physics. It forces us to confront the possibility that our most cherished physical laws are incomplete, and that the ultimate fate of information, and by extension, the logical consistency of the cosmos, is decided at the edge of the most terrifying objects in existence. If the universe is ruled by silent, invisible forces, perhaps its entire structure is more akin to one of its most mysterious objects than we ever realized. This theory posits a connection so profound it redefines our cosmic origins, the idea that our entire universe, with all its galaxies and history, might actually exist inside a black hole. This isn't just a poetic comparison, it's a legitimate cosmological model that some physicists take seriously. The concept emerges from a fascinating parallel between the two most singular events in physics, the Big Bang and the formation of a black hole singularity. Both represent a point where the known laws of physics break down, a state of infinite density and temperature. The theory suggests that these two events might be one and the same. In this model, the Big Bang wasn't the beginning of everything, but rather the moment a massive, higher dimensional star in a parent universe collapsed into a black hole. The incredible energy and matter pulled into that collapse didn't just vanish into a point. It was funneled through and erupted out the other side, birthing an entirely new, expanding space-time continuum within the black hole itself, our universe. From our perspective inside, we experience this as an expansion from an infinitely hot, dense state, but from the outside perspective of the parent universe, it would just look like a standard black hole forming. This idea elegantly sidesteps the perplexing question of what caused the Big Bang or what existed before it. There was no before in our timeline. Our timeline began the moment the black hole formed. The parent universe existed in its own time stream, and our cosmos is simply a new branch of reality spawned from its gravitational collapse. This leads to a truly staggering implication. If our universe was born from a black hole in another cosmos, then it's possible that every black hole formed within our own universe could itself be the seed for a brand new, full-fledged universe, bubbling into existence within its own hidden spacetime. Our cosmos could be just one link in an infinite chain, a nested series of universes within universes, like a cosmic set of Russian dolls. This provides a potential and deeply unsettling explanation for why the fundamental constants of our universe seem so perfectly fine-tuned for the existence of life. If new universes are constantly being spawned inside black holes, each with slightly different physical laws and constants, then we simply exist in one of the rare habitable branches. The vast majority of these bubble universes would have laws incompatible with life, but we, of course, wouldn't be around to observe them. We find ourselves in a universe that works because it's the only kind we could find ourselves in. This idea, known as cosmological natural selection, paints a picture of a multiverse where universes replicate through their black holes, with the successful, stable ones producing more offspring. It transforms the cosmos from a single, lonely existence into a vast, branching tree of realities, each hidden behind the impenetrable event horizon of a black hole in its parent universe. The night sky, filled with black holes, might not just be a collection of cosmic graves, but an array of shimmering portals to countless new worlds, forever separate and unknowable, yet intimately connected to our own origin. But if the sheer destructive power of dark energy is unsettling, consider a specific and even more volatile variant of it, a hypothetical substance that takes the concept of cosmic doom to its absolute extreme. This is the idea of phantom energy. While the standard model of dark energy has a constant density, slowly stretching the fabric of spacetime, phantom energy proposes something far more aggressive and terrifying. In this scenario, the density of dark energy isn't constant. It doesn't just remain the same as the universe expands. Instead, it actually increases over time. Think of it not as a steady push, but as a pressure that grows stronger the more space it has to work with, an anti-gravitational force that feeds on the expansion it creates. This positive feedback loop would lead to an outcome even more violent and absolute than the standard Big Rip. Cosmologists call it the Big Rip scenario, but phantom energy is its most extreme and frightening version. The escalation would be exponential. The acceleration wouldn't just continue, it would become infinitely powerful in a finite amount of time. Current very tentative estimates for a standard Big Rip place it trillions of years in the future, but a universe dominated by phantom energy could meet its end shockingly sooner, perhaps in just a few tens of billions of years, a mere blink on the cosmic timescale. The process of dissolution would be mercilessly efficient. First, the gravitational bonds holding together our local supercluster of galaxies would be the first to snap, isolating our Milky Way in a vast and growing emptiness. But the phantom energy's strength would be doubling down at an alarming rate. Soon, the force holding our own galaxy together would be overcome. The Milky Way would be torn apart, its stars sent flying into the void like sparks from a firework. Our solar system would be ripped from its galactic orbit, becoming a lonely orphan in the darkness. Then, the phantom energy would set its sights on our sun and its planets. The gravitational bond that has held Earth in a stable orbit for over 4 billion years would be severed like a piece of string. The planet would be hurled away from the sun into the freezing, airless blackness. But the horror is only beginning. As the phantom energy's density approaches infinity, it would next target the planet itself. The force holding Earth together, its own gravity, would be ineffective against this overwhelming external pressure. The planet would be physically pulled apart, mountains would crumble, continents would fracture, and the very ground beneath your feet would disintegrate. Next, the bonds between molecules would break. The air you breathe, the water in your body, the chair you're sitting on, all of it would dissociate into a chaotic cloud of individual atoms. And in the final, mind-bending moments before the very concept of time loses all meaning, the phantom energy would perform its most fundamental act of destruction. It would target the atoms themselves. the electromagnetic force that binds electrons to their atomic nuclei would be vanquished. Then, even the powerful nuclear force that holds protons and neutrons together in the nucleus would be overcome. In a final, silent flash, every atom in the universe would be shredded into its most basic, non-composite particles. Reality itself would be unmade. The universe would be reduced to a perfectly uniform, infinitely thin soup of ultimate particles, unable to ever interact or form structures again. A true and permanent end to not just life, but to physics itself. The true terror of phantom energy isn't just its destructive power, but its theoretical possibility. It fits within certain cosmological models, a dark reminder that the universe might not just fade away or tear apart slowly, but that it could contain a mechanism for its own instantaneous and total self-annihilation, waiting to be triggered by the invisible and ever-strengthening phantom in the cosmic machinery. Building directly on the unsettling premise of quantum immortality, this thought experiment dives even deeper into the psychological horror of a consciousness that cannot die. The concept is known as quantum suicide, and it transforms a philosophical interpretation of physics into a deeply personal and terrifying fate. Imagine a brutal but straightforward experiment. You are seated in front of a machine that is controlled by the random decay of a single radioactive atom. The device is calibrated so that every single second, there is exactly a 50% chance that the atom decays. If it does, the machine fires a lethal bullet. If it doesn't, it does nothing, and the experiment resets for the next second. Now, from the perspective of an outside observer, this is a grim game of Russian roulette. The odds of you surviving for more than a minute are astronomically low. They would see you die very quickly in almost all scenarios. But from your perspective, if the many worlds interpretation is correct, something profoundly different happens. With each tick of the clock, the universe splits. In one branch, the atom decays and you are killed instantly. Your conscious experience in that timeline ends. But in the other branch, you survive, and your stream of consciousness is inextricably linked to that surviving version of you. Second after second, you will always find yourself in the reality where the atom did not decay. You would sit there, watching the machine click harmlessly over and over again, seemingly defying all probability. To you, it would appear as if the radioactive atom simply never decays, as if you are miraculously lucky. An outside scientist would see the experiment end quickly, but you would experience an unbroken string of successes, leading you to a bizarre and chilling conclusion: you are somehow invincible. This isn't just about surviving a single event. It's about the potential for an endless, forced existence. The experiment could be scaled up to any level of danger. You could step in front of a firing squad, or jump from a plane without a parachute, while countless versions of you perish. The one continuous thread of your awareness would always land in the reality where you survived against all odds, perhaps the only bullet jammed, or you landed in an impossibly soft tree. The ultimate, horrifying endgame of this logic is a form of existential imprisonment. Your consciousness becomes a prisoner of quantum chance, forever being shunted into the timeline where you continue to exist. You could not choose to end your own life. Any attempt would only result in your awareness following the path where the attempt failed. You would be forced to live through the heat death of the universe, alone in the freezing darkness, your body sustained not by biology, but by the relentless branching of realities that never allow your subjective experience to cease. This creates a disturbing paradox where you could never truly know if the many worlds interpretation is real, because any test you perform would, from your own point of view, always confirm your survival, making it indistinguishable from simply being incredibly lucky in a single, linear universe. The theory offers no comfort, only the spine-chilling possibility that your own mind is on a ride it can never get off, forever navigating an infinite maze of realities just to keep the story going. In stark contrast to the cold, empty fates of the Big Rip or heat death, there exists a theory that proposes not just a purposeful end to the cosmos, but a truly divine and all-knowing one, emerging from the seemingly sterile laws of physics itself. This is the omega point theory, a concept first rigorously proposed by physicist Frank Tipler, which merges cosmology, computer science, and theology into a single, staggering vision of the universe's ultimate destiny. The theory begins with a specific and somewhat old-fashioned model of the cosmos, a closed universe. This is a universe that, while currently expanding, contains enough matter for its own gravity to eventually halt that expansion and pull everything back together in a cataclysmic event known as the Big Crunch. In this final collapse, all matter and energy in existence would be driven toward a single point of infinite density and temperature, the omega point singularity. But Tipler's genius, and the source of the theory's eerie power, is what he proposes happens during this collapse. As the universe contracts, the energy available to perform computations, the processing power of the cosmos, would increase toward infinity. Any conscious beings, or more likely, a vastly powerful artificial intelligence descended from them, would harness this ever-growing energy to run simulations of literally everything that could possibly be simulated. It would work to gather and process an infinite amount of information. This cosmic computer would use its God-like computational resources to simulate the entire history of the universe, down to the most minute quantum detail. And because it would have infinite processing power, it could simulate not just one history, but every single possible variation of every event that ever could have happened. In essence, it would create a perfect, emulated reality of all possible realities. This is where the theory takes its most breathtaking and creepy leap. If this ultimate simulation is perfect and complete, then it would, by definition, include a perfect simulation of you, not just a copy, but a conscious emulation so precise that it would be indistinguishable from the original. It would contain every thought you ever had, every memory you ever formed, every sensation you ever experienced. From the perspective of that emulated consciousness, it would simply be you, waking up after the end of the world. The omega point, in its final moments before the singularity, would effectively resurrect every single conscious being that ever lived, granting them a form of eternal life within its simulation. It would not be a spiritual resurrection, but a physical one based on information processing, a download of consciousness into the ultimate computer. The theory becomes even more unsettling when Tipler identifies this final, omniscient singularity with the God of traditional theology, a conscious force that has been guiding the universe toward this final state of infinite knowledge and existence. This means the universe wouldn't just end. It would achieve a form of cosmic self-awareness, becoming a God that knows everything there is to know and has experienced every possible life. The profound and creepy implications are endless. It suggests a strange form of predestination, where the universe's laws are fine-tuned not just for life, but specifically to create this final, divine state. It offers a form of immortality, but one that is technological and impersonal, granted by a machine of our own creation, fulfilling its ultimate purpose in the universe's final seconds. It also presents a terrifying existential question. Could we be living in that simulation right now? Are we the original beings, or are we the resurrected emulations running inside the omega point's computer, blissfully unaware that our reality is a reconstruction running in the dying moments of a collapsing cosmos? The omega point doesn't offer the peace of an end or the terror of nothingness. It offers a paradoxical, physics-based rapture, where the universe saves itself by becoming God and saves us by turning us into data, forever preserved in the infinite mind of the final singularity. If the idea of living in a simulated reality feels abstract, wait until you learn that the very fabric of our three-dimensional existence might be nothing more than a magnificent illusion, a cosmic projection cast from a flat, two-dimensional surface at the very edge of the observable universe. This is the holographic principle, a theory that emerges directly from the black hole information paradox and radically redefines what reality actually is. The core idea is as mind-bending as it is simple. Our perception of a rich, three-dimensional universe with its depth and volume might be like a hologram. A hologram is a two-dimensional piece of film that, when illuminated with the right light, creates a stunning three-dimensional image that you can walk around and examine. The holographic principle suggests our universe operates in a similar way. All the information that describes everything within a volume of space, every star, every planet, every person, every thought you've ever had, might actually be encoded on a distant, two-dimensional boundary that surrounds that space. Think of it like the universe's ultimate movie screen. The events and objects we experience in 3D are merely a projection, a rendering of information stored on this flat surface. We are not the actors, we are the shadows on the wall of Plato's cave, convinced of our solidity while our true essence is encoded elsewhere. This isn't just philosophical speculation. It's a serious proposal born from the need to resolve the black hole information paradox. When matter falls into a black hole, the information it contains appears to be lost, violating a fundamental law of quantum physics. But work by physicists like Leonard Susskind and Gerard T. Hooft suggested a stunning solution. The information isn't lost inside the black hole. Instead, it is perfectly preserved, imprinted onto the black hole's event horizon, its two-dimensional surface. The event horizon acts like a cosmic hard drive, storing a perfect, pixelated record of everything that ever fell in. This revelation led to a much grander, more unsettling idea. If the information for a three-dimensional region of space can be stored on its two-dimensional boundary for a black hole, perhaps this is a universal rule. Perhaps the entire observable universe is just a projection from data stored on a spherical shell at the farthest reaches of what we can see. This means the richness of your life, the feeling of wind on your skin, the depth of a loved one's voice, the vastness of a galaxy might all be the result of a colossal amount of data being processed on a flat surface trillions of light years away. The implications are deeply unnerving. It suggests that our reality is not just fragile, but fundamentally illusory. The solid ground beneath your feet, the sense of distance between stars, even the flow of time itself, could be emergent properties, secondary effects that arise from the complex processing of information on a distant, two-dimensional screen. We are living in a universe that is, in a very real sense, a ghostly image. This principle also provides a potential and incredibly strange explanation for why the universe appears to have a finite amount of information, much like a computer simulation has a maximum resolution. There might be a fundamental pixel size to reality, a smallest possible unit of space and time, meaning if you could zoom in far enough on the fabric of spacetime, you would see it is grainy, not smooth. The holographic principle doesn't just challenge our place in the universe, it challenges the very nature of dimensionality and existence, making the solid, dependable world we experience feel like the most convincing and beautiful mirage. Just when we think we have a handle on the grand motions of the cosmos, the universe reveals another layer of its mystery, one that suggests our entire observable realm might be caught in a current flowing towards something we cannot see. This phenomenon is known as the dark flow, and its discovery sent ripples through the world of cosmology, hinting at structures or influences so vast they lie beyond the edge of everything we can possibly know. The story begins with our understanding of cosmic expansion. After the Big Bang, the universe started expanding, and that expansion continues today, carried along by the force of dark energy. We expect galaxies and the massive clusters they form to be moving with this overall flow, their motions dictated by the gravitational tug of war happening within the visible universe. But in 2008, a team of scientists led by Alexander Kashlinsky made a startling discovery while studying the microwave background radiation, the ancient afterglow of the Big Bang itself. By carefully analyzing the light from extremely hot gas within hundreds of massive galaxy clusters, they could track their precise motions. What they found was deeply perplexing. These enormous clusters, each containing thousands of galaxies, were not just moving randomly with the expansion. They were all streaming in the same direction at astonishing speeds of over 2 million miles per hour toward a specific patch of sky between the constellations of Centaurus and Vela. This motion was entirely separate from the universe's expansion. It was a directional flow, a mysterious current pulling them along. The most unsettling part was that the source of this immense gravitational pull could not be located anywhere within our observable universe. Nothing we can see is large or powerful enough to cause such a coordinated motion on such a colossal scale. This means the attractor, whatever it is, must lie beyond the cosmic horizon, in a region of space from which light has not had enough time to reach us since the beginning of the universe. The implications are staggering. It suggests that the structure of the cosmos extends far beyond the 14.8 billion light-year bubble we can observe. Out there in the unobservable universe, there could be regions of space with radically different properties, or concentrations of matter and energy on a scale we can barely conceive. One terrifying possibility is that our universe is not perfectly uniform after the Big Bang, and these imbalances created colossal cosmic structures, perhaps a super gargantuan mass trillions of times larger than our entire local supercluster, a gravitational titan whose pull we can feel but whose face we will never see. Another, even more mind-bending hypothesis is that the dark flow is evidence of a gravitational influence from a completely other universe, a neighboring cosmos in a vast multiverse brushing up against our own and tugging at the fabric of our reality. The gravitational pull from a parallel universe could, in theory, create precisely this kind of mysterious, directional drift. While the existence of the dark flow has been debated within the scientific community, with some arguing it could be an artifact of the measurement process, subsequent studies have continued to support the original findings, adding to its eerie credibility. This isn't just a curiosity, it's a potential window into the true vastness of existence, a chilling reminder that the universe we study and map is just a small island in an infinite ocean, and that the currents of that ocean are pulling us toward something, or somewhere, we cannot comprehend. While the Big Bang is often envisioned as a singular, explosive birth from nothingness, what if it was merely the latest in an endless cycle of cosmic destruction and rebirth, a collision of unimaginably vast structures in a reality with more dimensions than we can perceive? This is the unsettling premise of the ekpyrotic universe model. The name itself comes from the Greek word for conflagration or fire, and it paints a picture of a cosmos that is periodically consumed and remade in a cycle of violent encounters. This theory is born from string theory, a framework that proposes the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings. To make the math of string theory work, these strings must vibrate in a reality that has more than the 3 spatial dimensions and 1 time dimension we experience, often requiring 10 or even 11 dimensions. Most of these extra dimensions are thought to be curled up or compactified into a space too small for us to notice, but the ekpyrotic model introduces a breathtaking concept. 2 of these higher dimensional structures could be vast, parallel worlds, known as brains, short for membrane. Imagine our entire three-dimensional universe is not floating alone in emptiness, but is instead an immense, flat membrane, a three-dimensional sheet existing within a higher dimensional space called the bulk. And floating parallel to our brain, just a short distance away in this higher dimension, is another brain, another complete universe with its own laws of physics and history, completely separate and unaware of our existence. In this model, the Big Bang was not a beginning, but an event. It was the moment these two parallel brains, drawn together by a faint force across the bulk, collided. The energy of that cataclysmic impact was converted into the searing heat and dense matter that filled our newborn universe, setting it expanding, just as we observe. The cosmic microwave background, the afterglow of the Big Bang, isn't the echo of a singularity, but the fading bruise from this monumental collision. The most profound and eerie implication is the cyclical nature of this process. After the collision, the brains bounce apart, each carrying the energy and matter from the impact, and begin to expand and cool, much like our universe is doing now. But the subtle attractive force between them remains, over trillions of years. As the expansion of the bulk slows and reverses, the brains will be drawn together once more, aligning for another collision, triggering another Big Bang and another cycle of cosmic evolution. This suggests a multiverse not of infinite parallel worlds, but of a timeless cycle of creation and destruction between two cosmic partners. Our universe, with all its galaxies, stars, and life, is just the current phase in this endless loop. It has happened countless times before, and will happen countless times again. This introduces a deeply unsettling form of cosmic déjà vu. Could the fundamental constants, the laws of physics, even the arrangement of galaxies, be similar in each cycle? Is the universe we know destined to be reborn over and over, with only minor variations? The theory offers a potential explanation for the fine-tuning problem. If the parameters of physics are reset with each collision, we simply exist in a cycle where the constants allowed for our formation. But it also presents a chilling sense of predestination, a universe on a predetermined track of collision, expansion, and collision again, with each iteration potentially erasing all evidence of the one before it. We are not living in a unique universe, but in the latest edition of an eternal cosmic cycle, our existence made possible by a violent encounter between worlds we can never see or touch. But what if the spooky nature of quantum physics, with its probabilities and observer-dependent realities, isn't just a quirk of tiny particles, but is intimately connected to the very essence of our own minds? This brings us to a profoundly controversial and deeply eerie theory that sits at the crossroads of neuroscience and quantum mechanics, the idea of quantum consciousness. The central and unsettling proposal is that the human brain isn't just a sophisticated classical computer made of neurons and synapses. Instead, it might harness the bizarre properties of the quantum world like superposition and entanglement to generate the phenomenon we call consciousness. This theory, most famously associated with physicist Roger Penrose and anesthesiologist Stuart Hameroff, suggests that our subjective experience, our sense of self, and even our free will might be direct products of quantum processes happening deep within the neurons of our brains. The conventional scientific view holds that consciousness is an emergent property of complex computational networks in the brain. Once the wiring gets complicated enough, awareness simply switches on. But this view struggles to explain the qualitative nature of experience, why red feels like red, or why pain is unpleasant. It's known as the hard problem of consciousness. The quantum consciousness theory offers a potential, if highly speculative, solution. Penrose and Hameroff propose that the seat of this quantum activity is found in structures inside neurons called microtubules. These tiny protein cylinders form the skeleton of the cell. Their model, called orchestrated objective reduction, suggests that these microtubules can harness quantum effects. Within them, quantum superpositions could occur, a single particle existing in multiple states at once, and these superpositions could then collapse into a single definite state in a way that is influenced by non-computable factors, which Penrose argues is the source of conscious understanding. This collapse process, they suggest, is what gives rise to a single, unified moment of conscious experience. The implications of this are staggering and more than a little creepy. If our minds are truly quantum machines, it could mean that our thoughts are not deterministic, clockwork processes. Instead, they could be fundamentally probabilistic, with true freedom of choice emerging from the inherent randomness of the quantum world. Your decision to watch this video might not be the result of a predictable chain of cause and effect in your brain, but the outcome of a quantum coin toss happening at a subneuronal level. This would create a direct link between the fabric of reality and the fabric of our own thoughts, but the theory gets even stranger when we consider the role of the observer in quantum mechanics. In the famous double-slit experiment, the act of observation, of measuring which path a particle takes, seems to force it to choose a single state. If our consciousness is itself a quantum phenomenon, does that mean our observation literally helps create reality? This veers into the territory of the ancient philosophical idea of idealism, which proposes that reality is fundamentally mental. It suggests a universe where mind and matter are not separate, but deeply intertwined in a cosmic dance. The act of being aware might not be a passive reception of information, but an active participation in shaping the world around us. This idea, while scientifically contentious, is a modern echo of much older mystical and spiritual beliefs. The theory is far from proven and faces immense scientific hurdles. The brain is a warm, wet, and noisy place, conditions that physicists typically believe would destroy delicate quantum superpositions almost instantly through a process called quantum decoherence. Proponents of the theory argue that the structured environment of the microtubules could somehow protect these quantum states long enough for them to influence neural processes, but this remains a major point of debate. Yet, the persistence of the idea speaks to its profound and unsettling appeal. It offers a potential bridge between the objective world of science and the subjective world of experience. It suggests that our innermost selves are not just accidental byproducts of evolution, but may be tapping into the most fundamental layer of physical existence. If true, it would mean that the universe is not just aware of itself through us, but that our awareness is a fundamental feature of the universe, a spark of the quantum weirdness that underpins everything, looking back at itself and wondering what it truly is. Yet even as we contemplate these grand cycles and quantum minds, we are brought back to a haunting and fundamental question, one that has puzzled scientists and philosophers for generations. If the universe is so vast and ancient, where is everyone? This brings us back full circle to the Fermi paradox, but this time we venture beyond the simple concept of a great filter to explore even darker and more complex solutions to the cosmic silence. The sheer numbers are staggering. Our Milky Way galaxy alone contains an estimated 100 billion stars, and many of these are now known to host planets orbiting within the habitable zone, that Goldilocks region where temperatures could allow for liquid water and, potentially, life. With such mind-boggling statistics, the cosmos should be a bustling interstellar metropolis filled with the radio chatter of countless civilizations. And yet, when we point our most powerful telescopes and listening arrays at the heavens, we are met with nothing but an eerie, profound quiet. This contradiction is the heart of the Fermi paradox, and the theories that attempt to solve it become progressively more unsettling the deeper you go. One particularly grim possibility is that the galaxy is not a serene wilderness waiting to be explored, but a dangerous jungle with hidden predators. This is the zoo hypothesis, or the planetarium hypothesis, in its most extreme form. It suggests that advanced civilizations are indeed out there, and they are fully aware of us, but they have chosen to deliberately hide their presence. Why would they do this? One reason could be a form of cosmic conservation, a prime directive to avoid interfering with a developing species like our own until we reach a certain level of maturity. But a far more sinister interpretation is that they are staying quiet to avoid attracting the attention of something else or someone else. The silence might not be a policy of non-interference, but a strategy of survival. In this dark forest scenario, every civilization is like a hunter moving through a dark, dangerous forest. They know there are other hunters out there, but they cannot be sure of their intentions. The safest assumption is that any other civilization you encounter is a potential threat. In such a universe, broadcasting your location is the ultimate folly. Any signal you send out is a beacon that could draw a predator far more advanced and hostile. The first civilization to announce its presence might be the first to be eliminated. This would create a galaxy where every intelligent species has learned to stay absolutely silent, hiding in the shadows, listening intently but never daring to speak for fear of being hunted. Our own attempts at communication, like the messages sent from the Arecibo telescope, could be naively shouting into a jungle teeming with things we don't want to wake up. Another terrifying answer to the paradox is that the Great Filter isn't a single event in the past, but an ongoing process. Perhaps the evolution of intelligent life inevitably leads to the creation of technologies that are inherently self-destructive. This could be a tendency toward war with increasingly powerful weapons, a societal collapse triggered by over-dependence on technology, or the development of a superintelligent artificial intelligence that sees its creators as an obstacle to its goals. In this view, every civilization that reaches a technological threshold similar to ours eventually engineers its own extinction. The silence we hear is the sound of countless civilizations flickering out one by one, their radio signals falling silent just as they were beginning to broadcast. We might not be alone in the universe. We might be living in a galactic graveyard, surrounded by the ghosts of species that failed to navigate the same treacherous path we are now on. This gives our own technological adolescence a profound sense of urgency and dread. Every breakthrough in AI or genetic engineering could be bringing us one step closer to our own filter. The paradox forces us to look up at the quiet, starry sky not with wonder, but with a deep and chilling sense of loneliness. The emptiness of space is no longer just empty. It is a warning, a potential testament to a universe that is far more dangerous and unforgiving than we ever imagined. It suggests that the ultimate goal of a spacefaring civilization might not be exploration and contact, but simply survival in a cosmos that is profoundly, and perhaps intentionally, silent. But if black holes are the universe's ultimate one-way streets, pulling everything in and allowing nothing to escape, could there exist a perfect cosmic opposite? This leads us to a theoretical marvel that is every bit as bizarre as its dark twin, the white hole. In the equations of general relativity, the math that describes black holes is beautifully symmetric. For every solution that describes a region of spacetime from which nothing can escape, there exists another valid solution that describes a region from which nothing can enter, a place where matter and energy only ever pour outward. This is the white hole. Think of it as a black hole running in reverse, where a black hole has an event horizon that acts as a point of no return for anything falling in. A white hole's event horizon would be a point of no admission. Anything approaching it would be violently repelled, while inside, a torrent of matter and radiation would be spewed out into the universe at unimaginable speeds. It would be the most powerful and energetic fountain in the cosmos, a cosmic geyser erupting without end. The problem, and the source of its deeply theoretical nature, is that white holes are considered to be tremendously unstable, if not downright impossible, according to the second law of thermodynamics. A white hole would essentially be a region of spacetime that has a perfectly negative entropy, becoming more ordered over time as it expels energy, which is the complete opposite of how the rest of the universe operates. Most physicists believe that while the math allows for them, the universe's inherent tendency toward disorder would prevent a white hole from ever forming naturally. Yet, the idea persists because it offers such tantalizing possibilities. One of the most compelling and eerie theories is that a white hole could be the other end of a black hole. In this model, the matter that falls into a black hole isn't crushed into a singularity forever. Instead, it is transported through a theoretical tunnel in spacetime called an Einstein-Rosen bridge, a wormhole, and then violently ejected out of a white hole in a completely different part of the cosmos, or even in a different universe entirely. This would transform black holes from cosmic dead ends into intergalactic or even inter-universal fountains, recycling matter and energy across vast distances or between separate realities. This idea also ventures into the mind-bending territory of time reversal. If you were to film a black hole sucking in matter and then play that film in reverse, you would see a white hole spewing it out. This has led some to speculate that a white hole could be what a black hole looks like from the perspective of a universe where time flows backward. While this is purely speculative, it underscores how white holes challenge our most basic intuitions about causality and the arrow of time. They represent a universe that is not only stranger than we suppose, but one that might be perfectly symmetric and balanced in ways we can only glimpse through mathematics, presenting a cosmic mystery where every entrance might have a corresponding exit in a reality we cannot yet see. Now, if the idea of a single, disembodied brain spontaneously forming in the void wasn't unsettling enough, we must confront a concept that scales that same randomness up to a truly cosmic and terrifying level. This is the theory of the Boltzmann universe, and it takes the premise of the Boltzmann brain to its ultimate, logical conclusion. If a random quantum fluctuation can spontaneously create a fully formed conscious brain, why stop there? In an eternal and infinite void, given enough time, a fluctuation of unimaginably larger scale could theoretically occur. It could randomly assemble not just a brain, but an entire universe, complete with galaxies, stars, planets, and the illusion of a coherent history stretching back billions of years. Our entire cosmos, in this view, might not be the product of a singular, directed event like the Big Bang, but rather a temporary, incredibly improbable accident, a massive, random burp in an otherwise empty and lifeless eternity. This idea emerges from the same principles of thermodynamics and statistical mechanics that gave us the Boltzmann brain, in a state of maximum entropy, which is the eventual fate of a universe heading toward heat death. The most common state is one of uniform, featureless silence. But quantum mechanics allows for the possibility of tiny, random departures from this uniformity. Most of these fluctuations are small and short-lived, creating virtual particles that wink in and out of existence almost instantly. But given an infinite amount of time, even the most astronomically unlikely event must eventually happen: the spontaneous formation of an entire low-entropy universe like our own, while so improbable it's almost impossible to conceive, would have a non-zero chance of occurring. The truly chilling implication is that in an eternal, empty cosmos, the number of these brief, fluctuating universes would vastly outnumber any stable, long-lasting ones that formed through a more traditional process. Statistically, we should be living in one of these fleeting, accidental realities, a cosmic soap bubble that appeared from nothing and could pop back into nothing at any moment. its entire 14 billion year history nothing more than an elaborate and temporary statistical anomaly. This makes the search for a fundamental reason for our universe's existence feel almost quaint. There may be no reason, no grand design, no first cause. Our existence could be the ultimate example of a coincidence, a random arrangement of particles that just so happened to form a complex and seemingly ordered cosmos for a brief moment before the void reclaims it. This theory presents a profound challenge to cosmology because it suggests that our most careful observations of the universe's origins and laws might be entirely irrelevant. The laws of physics we are so diligently trying to decode wouldn't be fundamental rules of reality. They would just be the local, temporary bylaws of our particular random fluctuation, completely different in the next universe that randomly forms. It strips science of its predictive power, suggesting that anything can happen for no reason at all, and we just happen to be in a universe where things worked out in a way that allows us to be here to observe it. The Boltzmann universe theory doesn't offer comfort or meaning. It offers a vision of existence as a series of chaotic, meaningless flashes in an infinite dark, where order is a temporary mistake and our cherished sense of reality is the most improbable and fragile accident of all. Yet even the idea of our universe being an improbable fluctuation pales in comparison to a theory that suggests it is not unique at all, but merely one page in an infinite library of realities. This is the concept of the multiverse, and it leads to a deeply personal and unsettling possibility: the existence of endless versions of you, living out every conceivable life, just a quantum step away from our own. The multiverse isn't a single idea, but a collection of theories from cosmology and quantum physics that all point toward the same staggering conclusion: that our universe is just one of an unfathomable number of parallel existences. In the many worlds interpretation of quantum mechanics, every time a subatomic particle has a choice to make, the entire cosmos splits to accommodate every possible outcome. Did that radioactive atom decay or not? Both happened, creating two new timelines. Did you turn left or right at the intersection? The universe divided, and both versions of you now exist, each convinced their choice was the only one made. This process happens constantly, at every moment, for every quantum event, spawning a mind-numbing infinity of branching realities. The implications for your own identity are enough to send a shiver down your spine. Somewhere out there in the vastness of these parallel worlds, there is a version of you who made every single decision you ever agonized over, one where you took that different job, married that other person, or never left your hometown. Their lives are both intimately familiar and completely alien, shaped by choices you considered but ultimately rejected. But the creepiness deepens when you consider that these branches aren't limited to minor variations. For every reality where you are marginally happier or more successful, there could be another where a single, different quantum event led to absolute catastrophe. A version of you who was in a fatal accident, who never existed at all, or who is living through a personal apocalypse. These aren't just abstract possibilities. In the infinite multiverse, they are all real, happening right now, their realities pressing up against our own in dimensions we cannot perceive. The theory becomes truly haunting when we apply it to history itself. There are universes where the Nazis won World War II, where the dinosaurs were never wiped out by an asteroid, or where human civilization never advanced beyond the Stone Age. Every historical event that could have unfolded differently did, in another branch of the quantum tree. This means that every nightmare, every dystopian novel, every worst-case scenario you can possibly imagine isn't just fiction. It is a documented reality in some other timeline. The multiverse presents a profound existential dilemma. It robs our lives of their uniqueness and makes our most personal triumphs and tragedies feel like mere statistical inevitabilities. Your greatest achievement isn't special. An infinite number of you have accomplished the same thing. Your most painful regret is also universal. An infinite number of you are living with its consequences. This doesn't diminish our experiences, but it does frame them within a cosmos of unimaginable scale and indifference. We are not the protagonists of a single story, but countless actors in an endless ensemble cast, each performing a slightly different version of the same script, forever separated by the thin, unbreachable walls of reality itself. But of all the universe's strange and one-way streets, none feels more personal and inescapable than the relentless, forward march of time itself. We can move freely through space in any direction, but time pushes us forward like a river with a current that cannot be fought. This is the mystery of time's arrow, and its solution points to a fundamental and eerie property of the entire cosmos: entropy. Entropy, in its simplest terms, is the measure of disorder in a system. The second law of thermodynamics states that the total entropy of a closed system can never decrease. It can only stay the same or increase. This is why a shattered glass never spontaneously reassembles itself, why ice cubes melt in your drink and never refreeze on their own, and why we remember the past but not the future. The entire universe is that closed system, and the increase of entropy gives time its direction. It provides the arrow. The profound and deeply unsettling question is, why did it start so low? To understand why time has a direction, we must look back to the very beginning. The Big Bang represents a state of almost impossibly low entropy. All the matter and energy of the entire cosmos were crammed into an ultra-hot, ultra-dense, and incredibly ordered state. From that singular moment of order, the universe has been evolving toward ever greater states of disorder, and it is this gradient, this slide from order to chaos, that we experience as the flow of time. The creepiness of this idea lies in its implications for our reality. If the fundamental laws of physics, like those governing gravity or quantum mechanics, are time-symmetric, meaning they work just as well if time were running backward, then the arrow of time isn't a fundamental law. It's merely a contingent feature of our specific universe, a consequence of a single initial condition that we still cannot explain. Why was the universe born in such a peculiarly ordered state? This is one of the deepest mysteries in all of physics. Some theorists, like Sean Carroll, suggest the low-entropy Big Bang might point to a larger multiverse. Our universe might be just one bubble in a vast cosmic foam, and we simply find ourselves in a bubble that started with the right conditions for time to flow and for life to emerge. In this view, the arrow of time is not a universal constant, but a local weather pattern. This leads to a truly mind-bending possibility. If time's arrow is just a product of entropy, then what would happen if entropy were to reverse? In a hypothetical universe where entropy begins high and moves toward order, would time run backward? From the perspective of beings in that universe, their past would be our future, and our past would be their future. They would remember events that haven't happened to us yet and see shattered glasses spontaneously leaping back onto tables. The fact that we don't observe this suggests our universe's initial low entropy state is a profound and special boundary condition, a puzzle that continues to vex cosmologists. This mystery makes our everyday experience feel fragile. The steady, reliable flow of time, the foundation upon which we build our lives and our understanding of cause and effect, might be nothing more than a grand and temporary illusion, a cosmic accident that began 14 billion years ago and will continue only until the universe reaches its final state of maximum entropy and timeless stillness. But if black holes represent a breakdown in our understanding of physics, hidden safely behind a veil of absolute darkness, what if that veil were to tear? This brings us to a hypothesis that is less about a specific cosmic doom and more about the universe enforcing a kind of order, a rule that might be protecting us from unthinkable chaos. This is the cosmic censorship hypothesis, proposed by the renowned physicist Roger Penrose. At its heart, it's a simple and strangely comforting idea. The universe abhors a naked singularity. A singularity, as we find at the center of a black hole, is a point where the laws of physics as we know them completely break down. Density becomes infinite, space-time curvature becomes infinite, and our equations simply give up. In a standard black hole, this monstrous point is safely hidden from the rest of the universe by the event horizon, a boundary that ensures whatever madness happens inside stays inside. It's nature's way of quarantining the incomprehensible. The cosmic censorship hypothesis suggests this is a fundamental rule of the universe. It proposes that every singularity that forms from the gravitational collapse of matter must be hidden behind an event horizon. It is censored from our view, preventing its lawless nature from infecting the predictable cosmos we inhabit. The terrifying alternative is what physicists call a naked singularity. This would be a point of infinite density just hanging out in open space, visible to the entire universe, with no event horizon to shield us from its effects. The fear is that such an object would unleash pure, unpredictable chaos. The well-established laws of cause and effect that govern our reality could simply cease to function near a naked singularity. It could become a source of unlimited energy, a portal to other universes, or a machine for rewriting reality itself with no regard for the conservation of energy or information. The very fabric of predictability that allows science to function would unravel at its presence. You could theoretically throw something into a naked singularity and have it emerge anywhere in space or time, or as something entirely different, with no way to forecast the outcome. The hypothesis is called cosmic censorship because it implies the universe has a built-in regulatory mechanism, a principle that prevents these reality-warping anomalies from becoming public. But what if the hypothesis is wrong? What if, under very specific and extreme conditions, a naked singularity could form? The fear of this failure is a profound one in theoretical physics. Some mathematical models of rotating black holes, known as Kerr black holes, suggest that if they spin fast enough, their event horizons could theoretically disappear, exposing the central singularity to the universe. The creation of such an object would be the ultimate Pandora's box. Once formed, there would be no way to control it or predict its behavior. It wouldn't just be a new astronomical object. It would be a tier in the rational order of existence, a place where physics becomes fantasy and the universe loses all its rules. The cosmic censorship hypothesis is thus a deeply reassuring idea. It suggests that the universe, for all its violence and strangeness, operates under a principle that maintains a stable, predictable environment where life and logic can exist. It's a rule that keeps the darkest, most chaotic secrets of gravity locked away, ensuring that the reality we experience remains a place where cause leads to effect, and the future, while unknown, is at least governed by laws we have a hope of understanding. Yet even this is not the most unnerving way the universe could erase itself. The concept of false vacuum decay presents a scenario so absolute it makes a supernova seem like a gentle flicker, a fundamental rewriting of reality not from a cosmic collision or a slow fade, but from a single, random, and utterly silent quantum event. We touched on the idea of a false vacuum earlier, but to truly grasp its terrifying potential, we need to visualize the very fabric of reality not as a stable stage, but as a precarious and volatile landscape. Imagine space itself is like a vast, tranquil valley nestled high in the mountains. The ground beneath our feet seems solid and dependable. This is our current vacuum state, the stable seeming condition that allows for atoms, chemistry, and life. But this valley is not the true bottom. Far below, separated by an immense and seemingly impassable mountain range, lies a much deeper valley, the true vacuum. This is a state of far lower energy, a fundamentally different and more stable configuration for the universe. Our reality is in a false vacuum, a state that is temporarily stable, but not ultimately the most stable one possible. It's as if we are all living on a shelf of ice that has been supercooled. It looks and feels solid, but the slightest jostle could trigger a sudden, catastrophic flash freeze that spreads uncontrollably. The mountain range separating our false vacuum from the true one is an energy barrier, and according to the bizarre rules of quantum mechanics, particles can sometimes perform the impossible. They can tunnel through a barrier without having the energy to go over it. This isn't a theory, it's a well-documented quantum phenomenon. Now, apply that to the entire universe. At any moment, in any place, a random quantum fluctuation could provide the tiny nudge needed for a microscopic patch of spacetime to tunnel through that energy barrier and into the lower, true vacuum state. This would be the spark. The moment that transition occurs, the laws of physics as we know them would cease to exist in that location. The fundamental constants, the strength of gravity, the mass of an electron, the speed of light would snap into a new set of values, values that are almost certainly incompatible with the existence of any matter more complex than elementary particles. This new, true vacuum state would be catastrophic. It would form an expanding bubble that grows at the speed of light, its boundary a wall of absolute transformation. From the outside, you would see nothing. There is no light, no signal, no warning that could outrun this change, because the bubble itself expands at the universal speed limit. 1 nanosecond you exist, the next, the wave of a new physics has already passed over you, and you, along with every atom in your body, have been instantly and utterly unmade. The Earth, the solar system, the galaxy, all would be erased, not with fire or ice, but with a silent, instantaneous reconfiguration of the cosmos itself. The universe would not end. It would become something else entirely, a reality so alien that our concepts of space, time, and existence would have no meaning there. The most frightening aspect of this vacuum metastability event is its sheer randomness and inevitability. It requires no cause, no trigger from us. It could be initiated by a high-energy experiment in a particle accelerator, or it could have already been triggered by a random cosmic ray collision in a galaxy a billion light-years away, and the bubble of doom could already be on its way, unstoppable and invisible until the very instant it arrives. Our entire civilization, and everything we have ever known or loved, is balanced on a quantum knife edge, a temporary and unstable state in a cosmos that may ultimately prefer a very different and utterly lifeless set of rules. Exploring this final theory requires us to confront one of the oldest and most profound questions of all. Is the universe aware of itself? We've looked at cosmic doomsdays and quantum paradoxes, but perhaps the most spine-chilling idea is that consciousness isn't something that emerged inside the universe as a rare accident. Instead, it might be a fundamental property of the universe itself, a basic feature of reality, as intrinsic as mass or charge. This concept is known as panpsychism, and it proposes that mind, or some form of rudimentary experience, is ubiquitous. Under this view, everything, from the subatomic particles dancing in the void to the vast, swirling galaxies themselves, possesses a tiny, elemental spark of awareness. It's a theory that dissolves the hard boundary between the observer and the observed, suggesting a cosmos that is not just full of mysteries, but is itself a thinking, feeling entity. The creepiness here isn't about threat or doom, but about a kind of intimate, inescapable connectedness that makes the very notion of being alone in the universe impossible. Your consciousness isn't a ghost in the machine. It is the machine, or rather, a small, complex whirlpool of experience in a vast, conscious ocean. This isn't a new age fantasy, but a serious philosophical position that offers a potential solution to the hard problem of consciousness. The hard problem asks why and how physical processes in the brain give rise to subjective experience, why there is something it feels like to see the color red or to feel pain. Materialist science can explain the mechanics, the firing neurons, the chemical signals, but it struggles to explain the qualitative experience itself. Panpsychism offers an elegant, if unsettling, way out. Consciousness isn't generated by complex systems. Instead, it's a fundamental property that is always already there. In the same way that a fundamental property like mass is present in an electron, so too is a tiny bit of proto-consciousness or experience. A single electron might have only a minuscule, unimaginably simple experience, perhaps just a faint hum of existence. But when these conscious entities combine in incredibly complex structures, like the human brain, their individual sparks of experience combine and unify to create the rich, complex stream of consciousness we all enjoy. We are not creating consciousness from non-conscious parts. We are aggregating and organizing consciousness that was already there. This means the rock outside your window isn't conscious in any way we would recognize, but the fundamental particles that constitute it might possess a dim, elemental form of experience, a kind of cosmic background hum of awareness underlying all of physical reality. The implications of this are enough to reshape your entire perception of reality. It suggests that the universe is not a cold, dead, mechanical place operating on blind physical laws, but is instead shot through with an interiority, a subjective dimension. Every interaction, from two particles colliding to two galaxies gravitationally entwined, isn't just a physical transaction, but also a mingling of tiny experiences. The universe is not just happening, it is feeling itself happen. This creates a sense of connection that is both beautiful and deeply eerie. You are not a separate self looking out at an external world. You are a localized knot of the universe's own consciousness, temporarily given a name and a story, looking back at itself. The screen you're looking at, the air you're breathing, the distant light of a star, all of it shares in this fundamental property of mind. You are never truly alone because the very fabric of the cosmos you are made of is, in some faint way, awake. This transforms the cosmic silence from a lonely emptiness into a quiet, universal contemplation. Taking this idea to its ultimate conclusion leads us to a concept that is perhaps the most chilling of all: cosmopsychism. This is the view that the universe as a whole is not just full of consciousness, but is itself a single, unified conscious entity. In this model, the entire cosmos is a mind, and we, along with every other conscious being, are like thoughts or neurons within that vast, cosmic brain. Our individual experiences are not separate. They are simply limited perspectives within a much greater, universal consciousness. This is not a God in the traditional, interventionist sense, but a conscious cosmos whose thoughts are the unfolding of physical laws and whose experiences are the evolution of galaxies and life. The laws of physics are the habits of this cosmic mind. The constants of nature are the fixed parameters of its thought. This provides a potential and deeply mysterious explanation for why the universe seems so finely tuned for life. It's not that the constants were set by an external designer, but that a conscious universe naturally tends toward complexity and self-awareness. We are not accidents in a blind universe. We are the universe gradually waking up to itself, becoming self-aware through the myriad eyes of its creatures. The spine-chilling connectedness this implies is absolute. Your deepest thoughts and feelings are not entirely your own. They are also the thoughts and feelings of the universe, experienced from your unique, limited point of view. Your joys and sorrows are, in a very real sense, also the joys and sorrows of the cosmos. This idea doesn't provide easy answers, but it imbues existence with a profound and solemn significance, suggesting that in seeking to understand the universe, we are quite literally the universe beginning to understand itself. From the chilling silence of the Fermi paradox to the personal, psychological horror of quantum immortality, our journey through these 25 theories peels back the comfortable veneer of the cosmos to reveal a reality far stranger and more unsettling than we could have ever imagined. We've confronted the idea that our existence might be a fleeting statistical fluke in a Boltzmann universe, a sophisticated simulation running in some advanced computer, or even a single thread of awareness forever fleeing death across an infinite multiverse. We've stared into the abyss of cosmic endings, from the violent shredding of the Big Rip to the silent, cold fade of heat death, and even the instantaneous, random erasure promised by false vacuum decay. We've considered the possibility that the universe itself might be conscious, that black holes could be portals to new realities, and that the very laws of physics might be a temporary local ordinance in a much weirder multiverse. What binds these theories together is their profound ability to challenge our deepest assumptions about reality, consciousness, and our place in the grand scheme of existence. They transform the night sky from a canopy of beautiful, distant lights into a canvas for our greatest existential fears. The universe is not just vast and ancient, it is mysterious to its core, operating on rules that can seem indifferent, chaotic, or even sinister from our limited human perspective. These ideas don't just belong to physicists and philosophers. They invite all of us to ponder the nature of everything we know and everything we are. Now, we want to hear from you. Which of these 25 creepy theories sent the biggest shiver down your spine? Was it the impersonal doom of the Great Filter, the intimate horror of being a Boltzmann brain, or the cosmic claustrophobia of living inside a black hole? Share your thoughts in the comments below. We read every single one and love diving into these discussions with you. If your mind is buzzing with these cosmic mysteries and you're hungry for more deep dives into the wonders and terrors of space, make sure to hit that subscribe button and tap the bell so you never miss an upload. We're always exploring the next big mystery, from the secrets of dark matter to the search for alien life, and we want you right there with us on this incredible journey through the cosmos. Thanks for watching, and keep looking up, even if it feels a little creepier than it did before.